Hi, it's your average Haskell girl Tuula and the Space Garden. Mainly I have been working on this screen. Now the player can move left and right, they can walk or climb up and down the ladder. The animation isn't in place here yet. And there's even a little hack here that if you are not aligned completely, the character is automatically raised to the surface level. So you don't have to do a pixel perfect alignment before you can walk off the stairs. The falling is not in yet, so you can walk in the air. That is going to be what I'm going to work on the next. And as you can see, some of the items or objects you go behind and some of those you walk in front of. I like how the feet of the character actually sink in the grass. And this pillar is one of those that you walk behind. And this pillar is one of those that you walk in the front. So that's all I did this week basically. And then how I have been doing that, let's close this one. So there's this simulate function that takes the current tick, state of the world, and then it returns a new state. Because the game is so simple, or demo rather, only thing we need to do is update the player location, player state. This tells if they are walking, climbing, standing still, the information when the animation started, and the current tick when the simulation of this specific frame was done. Okay, so we start by figuring out the desired direction based on the control state. So whenever the player presses or releases buttons on the keyboard, we are going to get an event. We are going to run the simulation for that very brief moment of time. And before we do that, we are going to update the control state. So it actually works in a way that if player hits right and up, then the pressing the right will trigger an event, causes the simulation so that the player moves a little bit to the right. Pressing up updates the control state, and that causes the simulation to run a little bit forward. And at that frame or that simulation step, the both right and up keys are pressed. And depending on the situation, something happens. And when all the events have been processed, then there's a one simulation step for just in case, because if there are no events to process, we still want to run the simulation before rendering anything on the screen. So if the player is standing completely still doing nothing, then no events are generated, but we still run the simulation. So we render the screen, simulate, render the screen, simulate. And if player is doing any action, then it's a render the screen, process each and every event, simulate until player hits ESC. So the desired direction just checks the control state. If the player is pressing left and right, then desired direction is nothing. Basically, the lateral movement is 0. If it's pressing left, then it's 1, pressing right, it's 1. I really should have some proper types here instead of just doubles. Excuse me. Now that we know which direction the player would love to go, we move the player here. And this is just a bunch of special cases. Originally, I was thinking that it would be really nice to have a simulation using forces and masses and such, and those would change the speed of the objects. And then I figured out that that's probably too complex to create right now. So I offered to write lots of special cases and then more special cases in such special cases. So fall first, it's not implemented as I showed you, so nothing, player will never fall. Climb up or down. So if player is pressing up, They could be pressing up or they could be pressing right and up, and this would trigger. It also checks if they can climb, and if they can climb, then we climb. If this doesn't trigger, then we check if are they pressing sideways and can they walk, or if they're not doing anything, then we just stand still. And then there's the otherwise clause that doesn't update anything, just in case if nothing of these matches. So we don't want to crash the program in that case. Climbing, for example, again, bunch of special cases. First we are taking the coordinates of the player. Those are in doubles, those are in the global space, turning them into the coordinates of the on a tile. So XD, YD, these are X divisor, Y divisor. These basically tell which tile the player is currently on, and the YM is the Y modulo. So that tells the coordinate, Y coordinate within the tile. We don't have the same for the X because we don't need that. And then can we climb is again a bunch of cases. Player happens to be at the very top, top row of the tile, and they want to go up. No, sorry, completely other way around. They're at the very bottom row of the tile. They happen to want to go down. There needs to be a ladder at the same X coordinate, but one row lower. And if all that is fine, then we return true. If we happen to be at the very top top row of the tile, we want to go up, then there needs to be a ladder on a tile above us. Then we can go up. Or if we are not at the top, or if we are not at the bottom going down or top going up, we are somewhere in the middle. Or we are in the bottom going up or top row but going down. It's enough that we are on a ladder tile, then it's true. Otherwise it's false. Like it's a bunch of special cases that can happen. And if that triggers, then we climb. And the climb is here. So basically it's just we are returning. I really should have proper types here, like direction as a double, delta tick, delta time as a word 32. It's even named incorrectly. It should be delta time and not tick. And then we are returning the new coordinates and new state. So X coordinate is, this is a trick. We are taking the current tile coordinate, multiplying it by 16 and adding 8. So we are centering the player on the ladder tile if they are climbing, because they can start going up or down of the ladder and they might be a little bit on the side. So we just center them in the middle. And then we take the new Y coordinate that we calculated here. So it's the current Y coordinate of the player added with the delta Y, basically direction we are going. It is either 1 or -1. Multiplied the player speed, multiplied by the delta time divided by 1000. Because the player speed is in pixels per second, but delta time is in milliseconds. That's why we have to divide it by 1000. It would be a good idea to actually, I will just write it down like this. Maybe I'll do it like this. I'm not sure. I have to think about what that affects, because then we would have to do the division here and do the from integral, but I don't worry about that right now. So now we have a new y coordinate, but we don't want to use that directly. We are going to climb it on the stairs. This is a more special cases. There's always more special cases. So if we happen to be at the ladder, then if this new coordinate lands on a ladder, then fine. We are not doing anything at all. But if it happens not to be a ladder, it happens to be something else. It's not an empty tile, but it's a wall. And we are going down. Then we are going to make sure that the new coordinate doesn't get into the ground. We stop at the boundary. So we stop at the bottom of the ladder. Same thing here. If the new location doesn't have anything, so it's an empty tile, there's no ladder there, we are going upwards, then we know that we have reached the top of the ladder, we are about to overshoot it, so again we stop right at the correct spot, which at the top of the ladder is not the ladder tile, but the tile above it and at the bottom row of that tile. Otherwise we just use it as it is. And that's how you do the climbing. Like I can show here maybe. For example, excuse me. Like here. This is a ladder tile. If we are here, our feet is right here and we press up. We don't want to overshoot and end up a couple pixels above the ground. We want to stop at this tile at this bottom row. And the same thing at the bottom, if we are here at the very bottom and press down, or if we are a bit above of the bottom, maybe we are in the same pixel, or maybe we are in here on the one row up and we press down and the new coordinate ends up somewhere here, for example at this dark green one. That's not what we want. We want it to be on this tile at the bottom row of pixels. That's what the clamp stairs does. And that's the climbing. That is actually the easy part. Walking sideways is a little bit more complex because there's more special cases here. Basically, what we are returning is again new coordinates and the state. And the new coordinates we get from the old x and y coordinates, where we in the x coordinate we add the delta x multiplied the player speed multiplied the delta time divided by 1000, because we are moving at a constant speed, but the time between the simulations varies depending on how quickly the player is pressing buttons and how quickly the program is in general running. But then we have a bunch of special cases that we are taking here. Like this is the new position is based on the current direction and the speed, but then we have to check, are we walking on a ramp, or are we leaving a ladder, are we walking down the ramp, are we colliding with the wall. If nothing of these happens, then we are just returning the new position as it is. That's good enough. But walking on a ramp, for example, like we happen to be on a ramp tile. This is a foreground tile that is either rising or falling ramp. These are actually hard-coded values in the source code, because I just choose to make the system to work with as simple as possible without having I was thinking that it would be really nice to have a vector graphics behind the scenes and use the that information to calculate how the player movement goes when they are walking towards a incline, and they would end inside of the incline, then the program would adjust the y-coordinate so that they are just on the surface of the incline. Could even do things like if when the incline gets steeper and steeper, then the player speed gets lower and lower because it's harder to climb on a steep incline than on a shallow one. And it could even make that you can run on a very steep incline, get a little some distance up, and then your speed falls to 0, and then you start sliding back. Things like that. But excuse me. But things like that would be quite a bit more complex, so I'm not doing those terms here. So if we are walking on a ramp, we are going to do the ramp adjusted location, meaning that if we are on a rising ramp, the x coordinate stays on the same. Rising ramp is a ramp that rises when you look it from left to right, and falling ramp is the one that falls when you look it from left to right. So we are just taking the x stays as it is, y in a rising ramp is the bottom of the tile minus the ramp offset. When it's a falling ramp, it's the top of the ramp plus the ramp offset. And the ramp offset is just in a falling ramp. It's higher on the left, so it's -1 there. It's lower on the right, so it's a 15 there. These are hard-coded values. I want them to be -1 actually causes the player to move on a tile that is above their current location. So because I can show it here, because here, if player happens to be on this pixel, then they are moved -1, so on this pixel, and they are on a completely different tile suddenly. And in between, it's the x coordinate. So here it's -1. Here was it 14? No, actually 15. Here it's 15. But here in the middle, it's x coordinate. So in the x coordinate 8, the displacement offset is 8, counted from here, because this is a 45-degree angle. And the reason why I have these here is that I want to have that -1 special case that places you on different tile, and I want to be absolutely sure that these offsets matches on the tiles on the either side. So that's how you move on the ramp. Leaving a ladder. One would think that this is nothing special, but as I showed you, when you are next to a cliff on a ladder, you are just a little bit underneath of that cliff. I don't want the player to have to align themselves pixel perfectly or go a little bit above the cliff before moving to the left so that they fall down a little bit. I wanted to make it in a way that if they are a little bit below the cliff and they move, then they are automatically lifted on the cliff. Just a couple pixels. So leaving a ladder is a bunch of special cases. So excuse me. So we have to be, the old location happens to be a ladder. The new location we are going is not a ladder. And the new location isn't ramp or empty tile. Actually, I don't think I have a place in the map where I would have a ramp next to a ladder. I should try and see what happens if player tries to interact with that. it probably doesn't work because of this check here. And then the tile that is above of that tile that we are going is empty. And the location in the tile coordinates is less than 8. So you are on roughly at the upper half of the tile where you are standing and you're trying to go to the left. Then it counts as leaving the ladder. And the ladder adjusted location is simple. We just take the x coordinate, we don't change at all. Y coordinate is the tile coordinates we are going, minus 1. So if we are this divisor of the y coordinate gets the tile. And because we are not taking the modulus, we don't know at what point exactly on that tile we are. We don't care about that. It's enough to know that we are on this specific tile. We subtract 1 and then we end up at the bottom of the next tile on the up. And that's how you get that effect of leaving the ladder and climbing on top on the cliff. Walking on a ramp, again, why is it here? It is because this is going down. Because if you think about it, we are taking the new position y coordinate and adding 1 to that, checking if that happens to be a ramp. And if it happens to be a ramp, then we are adjusting our location on that ramp. That is because, here's a good example. Let's put the grass out of the way. When player walks here, the y coordinate is at the bottom row of this tile. They step here. Now they are standing on an empty space. I don't have falling routines yet. I didn't want to use the falling routines here because if the player would fall from here to here, it would trigger the falling animation maybe, and it's a one frame. Player would not notice it most likely, but I just didn't want to do it like that. So I'm detecting this special case. When the player is here, steps here on the empty space, that check that I showed detects this case and adjusts this location to be on this ramp, on this tile, on this x coordinate, so it actually ends up here. Actually, it actually ends up here, but the ramp logic handles the adjustment. And if the game would be running really slowly, delta time would be really big. We would, for example, step from here to here. Then the ramp adjustment would move the player to here. So, like I said, the game is just full of special cases inside special cases inside of special cases, because I did not use a physics engine or some nice vector graphics representation, but decided that I thought that it would be easy enough to just play with tiles. Collides with wall. Player tries to walk, and they happen to be these locations. Has a bunch of locations because player is tiles are 16 times 16 pixels, but the player is 16 times 32 pixels. So when they are walking, we need to check the current tile that they are standing on and the tile above that to see if they are getting a collision. And I'm just checking that if either one of those tiles isn't an empty tile or ramp, then it's a collision. And that means that if there's a foreground tile that it has just a tiny bit of tiny bit of what's it called, ground on top of it. It's a tunnel, and it looks that the player could walk underneath it. They cannot walk underneath it because we are just taking into account whole tiles. I probably should clean up this part of the code because it is messy, because at some point I was thinking of doing partial tiles and such, but decided against it because it started getting a bit convoluted. So we are checking that tile their legs are and the tile their torso are, and if either one of those happens to be something else but one of these three, then it's a collision, and then we don't move. We just don't move if collision occurs. In realistically speaking, we should do this in a way that the player would move up to the point of the collision, so that they would stop just before that collision happens. Because we are, of course, doing discrete mathematics, the simulation runs in steps, so we should, if we wanted to be very precise, we would find the time spot where the player collides with the wall or whatever obstacle it is and move the player there, and use the rest of the delta time to simulate what happens when they try to walk into the direction where the collision occurs. But because we have 90-degree floors and walls, this wouldn't make much of a difference anyway. It would make a difference if we had inclines. So if for example, let's say, if the player could fly, they would be flying in a 45-degree angle. They would hit the wall. Then the speed that they have would carry them up to the point of the impact, and the rest would deflect upwards. So they would move a little bit upwards. But because all this happens in a milliseconds, tens of milliseconds, the player doesn't really notice any difference whatsoever, even when we just stop at the point where they wanted to start moving. The difference on the player end isn't noticeable. So we really just stop at that point instead of doing any fancy integration or time stepping or anything. Anyway, if they are not walking on a ramp up or down, they are not taking ladders, they are not leaving ladders, they are not colliding with wall, then we just update the new position to be the position we calculated here. This comment here, to do ladders properly. I'm not sure if I need this because we are walking. So we are moving in a sideways. And the movement on our, no, actually, yeah, I need to do this because this is a special case where the player is climbing on the ladder. So the animation is climbing animation. They stop and then they move laterally, sideways, without leaving a ladder. Then we don't want to trigger the walking animation. We want to keep the ladder animation running here. So they would be shuffling sideways. We could actually even have a different animation there. But I'll get to that at some point. But that's how I did the walking thingy. Standing still, nothing happens. Default case, nothing happens. So now we can walk around. We can climb up and down. We can go ramps up and down. We can go front and behind of the pillars and like, sorry, this one. Like, I just show it really quickly again. So we are going behind of these supports. We are going in front of the plant, but we are sinking in the grass. We are going behind this pillar, but front of this pillar. So how did I do that? It is done simply using layers. Like we have, this is actually, these are in the order even how we render things on the screen. First we render the background. On top of that we render a foreground. Notice that these two pillars are on the background, but this one isn't. Then we render the ladders. Then we render plants. Then we render player. So player is front of all this stuff that is rendered here. So if they are here, they are front of this pillar, they are front of this whatever weekly plant it is. Then we render fences. The layer is called fences because originally it contained only these fences, but now it contains this bridge support thingy and this pillar. Because these are rendered afterwards, if the player happens to be here, the pillar is covering them. And then we render grass. So if player is standing here, their feet nicely sink into the grass. And because this pillar and this background thingy are on a different layers, I don't need to have a special graphics for that pillar. But here, this pillar is a one that player walks in front of. So it's on a background layer like this. Meaning that I had to make a special pillar tiles that fit into the, when placed into the level next to these tiles. So this and this pillar tile are custom made for this specific situation. You can see them here actually. Like I can place them actually here. So here's the custom pillar and here's the regular pillar. Actually, not that one, but that one. So the pillar graphics is the same, but the another one of them has the background stone, that blue thing is behind of it. So it meshes seamlessly on that. I promised to show you as a sprite last time, so I'm going to show here. This I'm using the demo version that has the tilemap support, which allows me. There's tons of tutorials on about this, but I'm just quickly showing this. So here I have pillar graphics. If I press the control, it shows that this is tile number 64, 65, 66, 68, 67, 64. This tile and this tile is the same tile, even when they are placed on a different places. And if I have this setting that I'm modifying the existing tiles, if I draw here, you can see that these three tiles are actually the same tile placed on a different position. If I had create new tile setting, then it wouldn't create. But now it's a 74 instead of 64. And if I do here something else, oops, sorry, it's 75. So those it keeps track what tiles are different and gives you it basically just collects them here. And this is a feature that makes it really nice because you can, for example, here I have this land ground thingy. I have same tiles in multiple places because this tile wall on the left side, I wanted it to be meshing with these three tiles and in these two tiles here. So it's easier to do these things when I can just place the tiles how I would use them in the game, edit them so that every combination matches seamlessly. Like I don't even remember which one is the original now. I think that one, 8, must be the original, the middle tile. And it has a stones on the 4 sides, and that 8 tile here, it has to match with these tiles 2, 4, 5 and 9, and the number 2 tile has to match with the 9, so it's placed here too. Number 2 tile has to match with 1 and 3, and I think there was also 20 and 22. Like, these are the cliffs, but this tile here is a bottom of the cliff. Like here there's a empty space, but here there is no empty space, but this ground thingy continues a little bit on this tile. The more you have these details that continue from tile to tile instead of stopping at the squarely at the edge of the tile, the less the world will look to be built from the tiles. Of course, you can still see that it is tile based, but it doesn't have that grid effect that strongly, and that's why there's a different kinds of ground tiles that can be placed next to each other. There's a number 8 is that standard tile. There's a 2 tile fossil skull there. There's even a completely empty tile, and around that there's a sort other tiles. Like 8 tile has the stones on all edges, 13 has only on 3 edges, so it fits with the 8, and 12 that has no stones whatsoever. I could have more tiles that don't have any stones at the edges and have some special feature in the middle, like buried spaceship. That buried spaceship could be multiple tiles big. So that's why I really like the tile map editor in the Agemite. I also really like the sprite editor. This is the player character. It has 4 animations. It has the shown here. It's the standing right, then it's walking right, standing left, and walking left. I can have the animation running like this. And then each of these consists of multiple layers. Like, I can also only have the legs visible. I can have torso. Torso is a continuous, like these cells are linked to each other. So if I edit torso in one of the tiles, frames, it automatically updates to each and every frame. So I don't have to do the changes to multiple frames. Arm is just arm is just a little thingy waving back and forth. So when I'm animating something, I can just, I think I did it with the outline first. Yeah, this is actually the old outline that I started with. There used to be a hat, but it got dropped. So I can just start with something, outline, and then just animate some parts for it, like legs, and see that these work nicely. Then add arm, head that stays still in this one, and then the little antenna that waves back and forth. And this was kind of silly because that hair or antenna is black, and most of the background in the game is black, so it doesn't really, it's not really visible, only the red thing at the top. And the same thing is with all the other animations. I just have broken the animation in multiple layers, and then animate those, because it's much easier to animate for example, these falling things, particles, separately than to think about the whole thing, how it goes. Same thing with the tree, the trunk. This big person stays the same, only the branches wave around. And when I export this stuff here, I end up with a sheet like this. So these are the tiles that get placed on the map, and when rendering based on the current frame, I'm just choosing one of 6 frames. I wonder if I have a player, these tile sets, textures. Yeah, here's the player sprite. This is how the player sprite looks into when it has been exported. So the state is on the y-axis and the frames are on the x-axis. And when I add more animation, I just export them. They just end up here. I still need to have the climbing and falling animations. And then the spraying the water. Maybe I'll give them a watering can or something. Not sure. And when I'm exporting this one, I'm using a script here, export tileset, that I give a name of the PNG file that I'm exporting, and then the number of columns. And if I load it, the texture, so it should be here. And it was called tile map, that one. It's a completely black. This stumped me for a bit, like what in the earth is going on, but then I realized that it just doesn't have the correct palette. That one. We load that and now we have a, and this is the information the program is using. So when the tile map says that please place tile number 1 here, then it's this one. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And then there's empty tiles that don't have anything there. And then there was this mystery tile that I don't know where it comes from and why it is there, but it just happens to be there. Maybe there's something on some layer or something on the original. But anyway. And this is a PNG. It's indexed, so there's actually a color index. So we don't have RGB value for each and every of these, but we have that please use color number. For example, here in this part it says please use color number 1, which is this one. And this is the 0. And this palette is from the Nintendo Entertainment System. I just thought that it would be nice to have limited palette because it's a lot easier to edit things when you don't have 16 million colors to choose from. Like if you have 2 colors to choose from, it's really easy because it's a 50-50 chance to get it correctly, even if you are guessing. And if you have a 55 colors, like I have here, a bit less even because there's some colors are repeating, then it's a much more manageable, to me at least. So that's the asset sprite that I promised to show you. That's the code. Here's the map. And next week I'm really trying to see if I could make the falling animation and the climbing animation done and have the falling code into the code so that the player can actually shuffle sideways from the ladders and then just fall. That of course means that I have to figure out what happens when the player decides to jump from here, because there's nothing underneath. They just fall into the void. At that point, probably just spawn them at the starting position. Okay, but that's all for that's something that I will leave into the next week or even weeks after that.